step functions. Myself is Dr. S.S. Benchali, Professor, Department of Mathematics, Bishweshwar Engineering College, Bagalkot. So you may ask, what do you mean by unit step function? The unit step function, also called Heaviside's unit step function, how we are going to denote using this symbol u of t, and is defined as u of t is equal to 0 when t is less than 0. It means that the value of t is less than 0, the value of u of t is 0. Is it clear? And when t is greater than or equal to 0, what is the value of u of t? Is always 1. This unit step function is a curve which has value 0 at all points to the left of the origin and is equal to 1, or what we call it as an unity, on the right of the origin. Note that at t is equal to a step of unit height is formed, hence the name unit step function. Otherwise other notations to represent unit step functions are h of t minus a, u naught of t, u suffix a of t. These are the few notations usually we are going to use while defining unit step functions. Is it clear? Right? So graph of unit step function, as we have defined a unit step function. So when t is less than 0, it is always 0. When t is greater than or equal to 0, it will maintain 1 unit of height. Is it clear? And this is the t-axis, and it is a f of t. Okay, right? So next we shall define displaced unit step function. How we are going to denote u of t minus a? The displaced unit step function u of t minus a is defined as u of t is equal to 0 when t is less than a, u of t is equal to 1 when t is greater than or equal to a, where a is greater than or equal to 0. A means some constant. When t is greater than a on t-axis, you can choose some value. Is it clear? You are observing this graph, right? So when a is equal to 5u, it is 0. Otherwise, it is maintaining 1. Like that, you can vary a, right? It is always greater than 0. So function is displaced or shifted. How we are going to denote u of t minus a? Represents the curve u of t, which is displaced, or sometimes we may call it as an translated a distance a units to the right. Is it clear? I hope you are observing this graph. You will come to know what you mean by a displaced function, right? Say for example, sometimes they may ask you to calculate u of t minus 3 or u of t or 6 times of u of t minus 2. Is it clear? How we are going to draw these diagrams? Is it clear? Right? So u of t minus 3 means what? Less than 3. It means the value of t is less than 3, it is 0. Right? So greater than or equal to 3, it will maintain a unit height 1. Is it clear? So that is the meaning of u of t minus a. It means the curve is shifted to 3. Is it clear? On the t-axis, and this is the f of t. Exactly in the similar way, we can define u of t. Is it clear? Or I can say that u of t minus 3 is just like a switch, right? If t is less than 3, it is off. When t is greater than or equal to 3, a switch is on. So that is the meaning of u of t minus 3. Is it clear? How we are going to define u of t? It is as good as unit step function. When t is less than 0, it is 0. When t is greater than 1, it will maintain 1 unit height. Exactly in the similar way, you can define 6 times of u of t minus 2. U of t minus 2 means when t is less than 2, it is off. When t is greater than or equal to 2, it is on. Is it clear? Right? So what about the 6? We have multiplied by 6. In the earlier case, it was maintained 1 unit height. Here it is maintained 6 units height. That is the difference between u of t and 6 times of u of t, or u of t minus 2, 6 times of u of t minus 2. Is it clear? Okay, now we have defined 6 times of u of 2, right? Say for example, I can give one more example, live example. Say for example, I want to start a program, I just shot 20. Is it clear? Right? How we are going to write down is shot be 20 into u of t minus 3, or mat is equal to 0 and t is less than 3. It means this program is off before 3 o'clock. It means t means what? Time is less than 3. This program will on at time is equal to 3. Is it clear? At dip to class will off before 3 o'clock. This class will on at time t is equal to 3. Is it clear? Right? So the same thing can be written in terms of function f of t into u of t. It is 0 when time is less than 3. Right? So when t is greater than or equal to 3, you will get a function. Right? This is an analogy. Is it clear? So I hope it is clear. Right? Or I can give one more live example. Suppose I want to on a radio at a time t is equal to 1 hour or 1 p.m. Is it clear? On TV at time 3 p.m. On computer at time is equal to 4 o'clock. Is it clear? It means that radio will on at time t is equal to 1. It can be written as u of t minus 1 plus TV will on at 3 o'clock. How we are going to write down mathematically in this form. Computer will on at 4 o'clock. It can be written in this way. Or you can define a function g of t is equal to 0 when t is less than 1. It means before 1 o'clock, right, radio is off. Is it clear? TV is off. Computer is also off. Right? So in between 1 p.m. and 3 p.m. radio will on. Is it clear? Right? And 3 to 4 p.m. radio as well as TV will on. Is it clear? Right? After 4 o'clock, all the three equipments, namely radio, television, computer, will on. Is it clear? Either you can write down in this form or this concept can be written in this form. Is it clear? Right? Say for example, on radio at t is equal to 1, off radio on TV at t is equal to 3, off TV on computer at t is equal to 4. It means that suppose if you on radio, television, computer at a time, we cannot use all the three gadgets. Is it clear? And it is a national waste of electricity. For that reason, either I can use radio or I can use television or I can use computer. For that reason, I want to rewrite the same concept in a different form. How we are going to write on? Suppose if it is on, radio is on, right? I should off television and computer. Is it clear? Right? So like that you can write on when t is equal to 1, radio is on, right? Off radio at the time t is equal to 3, you can on television only. Is it clear? Off TV, you can on computer at the time t is equal to 4 o'clock. How we are going to write on? I want to use a particular method. Radio u of t minus 1 minus u of t minus 3. Is it clear? Plus television u of t minus 3 minus u of t minus 4 plus computer u of t minus 4. What it means? U of t minus 1 means radio will on. Is it clear? Right? At the time 3 is equal to minus no. At the time t is equal to 3, radio will off. Television will on. Is it clear? Right? At 4 o'clock, computer will on. Television will off. That is the meaning of this statement. Or we can write on the same concept using another method. Is it clear? Right? T minus 1, t minus 3, t minus 3. Is it clear? T minus 4, t minus 4 is common, no? For that reason, you can read it as radio u of t minus 1 plus TV minus radio. Radio will off, TV will on at 3 o'clock. Is it clear? Right? Plus computer minus TV at t minus 4. Computer will on, TV will off at 4 o'clock. That is the meaning of this statement. Like that, we can use the unit step function to define a real world example. Is it clear? Right? So unit step function u of t and u of t minus a are extensively used to represent a portion of the curve of the function f of t is as explained in the following cases. Is it clear? It means that they will give a curve. When you multiply by u of t, what happens? What is the resultant curve? Now I want to observe. Is it clear? Right? When f of t is multiplied by unit step function u of t, the resultant function f of t u of t will represent the part of the function f of t on the right of the origin, the part of f of t on the left of the origin being cut off. That is vanishes when t is less than 0. Is it clear? sometimes they may ask you to demonstrate sin t into u of t. Sin t is the given curve, u of t is the unit step function. Is it clear? I hope you are observing the graph of unit step function. This is the sine curve. If I multiply these two curves, what is the resultant curve? Is it clear? Right? So observe the sine curve. When t is less than 0, it is off. When t is greater than or equal to 0, it is on. That is the meaning of sin t into u of t. How we are going to define mathematically? 0 when t is less than 0 is equal to sin t when t is greater than or equal to 0. That is the meaning. Is it clear? I hope we have learned a lot of things from this graph. Another case is f of t into u of t minus a. It is a displaced unit step function. You can multiply these two functions. What is the resultant? I hope you are observing displaced unit step function. Is it clear? And f of t is equal to y is equal to t plus 1. So when you multiply these two, what is the resultant? Right? So resultant function is 0 when t is less than 2. Is it clear? T is greater than or equal to, it is on. What you are observing on the graph. This is the resultant part of the graph. Okay, right? So I want to consider another example. Sketch the graph of sin t into u of t minus pi. Is it clear? So this is the displaced function and sin t. So what is the resultant graph? You observe when t is less than pi, it is off. When t is equal to pi or greater than or equal to pi, it is on. That can be observed. Is it clear? Right? Similarly, t square sorry, t square into u of t minus a, displaced function, and it is t square. Multiply these two. What is the resultant curve? Is it clear? It is 0 when t is less than 1. It is on when t is greater than or equal to 2. I hope you are observing this graph. This is the resultant graph. When t is less than 1, it is off. T is greater than or equal to 1, it is on. Is it clear? It can be observed. Right? Exactly in the similar way, you can demonstrate t minus 2 into u of t minus 2. It will shift by 2 units. Is it clear? How we are going to shift? It is shift by 2 units. Right? So you can draw the f of t. Is it clear? Then you can translate. It is shifted to 2 units. Then you can draw the curve that can be observed. Is it clear? Right? Similarly, sine of t minus pi into u of t minus pi, shifted by pi units. Unshifted is sine t into u of t. Is it clear? This is the sine curve and it is shifted to pi. I hope you are observing these two graphs. You will come to know. Is it clear? Exactly in the similar way, t minus 1 whole square into u of t minus 1, t square, right? So and y of t square, it is shifted. Is it clear? Right? So similarly, the portion of the curve f of t lies between a and b. When t is lies between a and b, how we are going to define? U of t minus 2 minus u of t minus 4. It is 0 when t is less than 2. It is equal to 1 when t lies between 2 and 4. Again 0. T is greater than or equal to 4. Right? So you can draw the curve. When t is less than 2, it is off. When t is greater than 4, it is off. In between 2 and 4, it is on. How we are going to write down mathematically? We can write down in this form. Is it clear? Right? So exactly in the similar way, sometimes they may ask us to sketch sin t u of t minus 2 minus u of t minus 4. It can be defined in this way. The portion of the curve sin t lying between 2 and 4 is given by, I hope you are observing the curve. Is it clear? Less than 2, off. Greater than 4, it is off. In between 2 and 4, it is on. Is it clear? Right? So exactly in the similar way, y is equal to t plus 1 into u of t minus 2 minus u of t minus 4. Again it lies between 2 and 4. Is it clear? Otherwise it is off. Right? And similarly, sin t into u of t minus u of t minus 5 by 2. Right? When t is less than 0, it is off. When t is in between 0 and 5 by 2, it is on. Otherwise, again it is off. Is it clear? This is the sine curve. Right? So it is off in between 0 and 5 by 2. Right? That can be observed from the graph. Is it clear? And similarly, t square into u of t minus 1 minus u of t minus 2. Again it is on in between 1 and 2. Otherwise it is off. it clear? So exactly in the similar way, you can find out the Laplace transform of unit step function. Is it clear? By using the basic definition, you can define 0 to infinity e raised to minus st u of t dt is equal to 0 to infinity e raised to minus st u of t means it is 1. So by definition of unit step function, so what you will get? You will get 1 by s. Is it clear? Because I want to integrate e raised to minus st. Then you can substitute the limits, simplify. So finally you will get 1 by s. Exactly in the similar way, you can find out Laplace transform of unit displaced function. Again you can define by using the basic definition, right? So you can split into 0 to a to infinity. Is it clear? So here in between 0 to a it is 0, otherwise it is 1. Is it clear? Integrate and simplify. I hope you may obtain a to the power minus as divided by s, where s is